Yo, this is Coach Ray. Back at it again. We have a lesson today on solving rational equations. Just quick reminder, a rational is a fraction, and more specifically in this unit, it's a fraction that has a polynomial on top and a polynomial on the bottom. So we took these rationals leading up to now, we've multiplied them together, we've divided them, we've added them, we've subtracted them, and today we are solving equations that have rationals in them. Okay, so we are solving equations that have rationals in them. So when we add, subtract, multiply, and divide, we ended up with an answer that was usually a fraction with a polynomial on top, polynomial on the bottom. Now, because we're solving equations, our answer is going to be x equals something. X equals a number. So, kind of more specifically, it's going to be, more specifically, it's going to be an x where if I put it in every single spot here where there's an x, whatever that number is, it's going to make a true statement. Something minus something is going to be equal to something else. So whatever that number is, put in all those spots will make a true statement there. All right. Before we get into solving rational equations, off to the side here, I want to do a problem from the beginning of the year from our linear unit that relates big time to this. Okay, let's just do 2/3 x plus 1/5 equals 1/3 x plus 1. Okay, and do not miss this. I think this is really going to help with what we're doing today. Okay, in the very beginning of the year when we did solving equations with fractions in it, I just went under the assumption that most students your age hate fractions, which is usually true. And so I told you if you hate fractions, what you need to do is fall in love with LCD, least common denominator, because that will get rid of all your fractions always. So that's what we're going to do. We are going to find the LCD and use it to get rid of all these fractions. Okay, LCD. The way I described it back then was to look at all the denominators, 3, 5, and 3 again, and figure out a number that they can all go into. For today's purpose, I'm going to talk about a little bit different. One thing you can always do, it doesn't always give you the least common denominator, but it always gives you a common denominator, is you can always take all of the denominators and multiply them together. So in this case, there's 3 denominators, but only 2 numbers. So I'm going to write the LCD as 3 times 5. Yes, I know 3 times 5 is 15, but I'm not going to write it as 15. I'm going to write it as 3 times 5 because I think that'll help you today. All right, if I want to get rid of all the fractions, who remembers what I do with that LCD? Multiply it by every single term. Okay, so I take this LCD of 15, which I'm writing as 3 times 5, and I'm going to multiply it by every single term. In this red problem, I've got 4 terms. Okay, so it's going to look like this. And I'm going to keep writing my LCD as 3 times 5. I take this first fraction, 2/3 x, and I'm going to multiply it by 3 times 5 over 1. Okay, and I wrote it as a fraction because we're going to multiply straight across since it's a fraction. Okay, next term, 1/5, and I'm going to multiply that by 3 times 5 over 1. This 1/3 x, I'm going to multiply that by 3 times 5 over 1. And this last guy, I'm going to multiply by 3 times 5. Okay, I don't need to do over 1 there because it's not a fraction. All right, now watch very carefully what happens, and this is big time what's going to help you today, I believe. This is why common denominators get rid of fractions. There's a 3 on the bottom here in this 2/3 x and a 3 on top. Yep, I can cancel. I picked a number where there's a 3 in it, so obviously it's going to cancel with a 3. Here, 5 on the bottom, 5 on top, it canceled. I picked a number that had a 5 in it, so that it would cancel. Okay, again, here I have a 3 in the denominator. That cancels with my 3 up top. All right, so all I did was basically take a number that had all of the denominators in it so that it will cancel with all of the denominators. Let me write out what I have left and then I got you. Okay, so in my first term here, 3's cancel, so I have 5 times 2 times x, that's 10x. Next one, 1 times 3, so that's positive 3. Next one, 1 times 5 times x, so I've got 5x. And the last one, 1 times 3 is 3, 3 times 5 is 15. Okay, so I am not going to keep going from there, but using a common denominator, I can now get to a point where there are no more fractions. And that's what I'm going to do with my rationals today. Adriana.
Okay, so like, you know how like in 1/5 times 3 times 5 over 1, can you also cross out the 1?
You can also cross out the 1. So 1/5 times 3 times 5 over 1 you can cross out the ones. The reason I usually don't do it is because we just know that the ones are kind of just nothing. When we're talking about multiplication, 1 times something doesn't change anything, so they usually just kind of disappear when it comes to multiplication. All right, so now let's get to our example 1, this big old ugly thing. It says up top here that step 1 is find the LCD. There's actually a step before that, it's just kind of understood. In the rationals unit, the first thing that we always do is factor. I'm going to factor everything that I can. So this first term, x can't factor, and on the bottom, x minus 3 is just a binomial. There's nothing I can do to factor it. I'm going to write my binomials in parentheses, though, because we're more used to looking at them like that. Okay, minus. All right, 2x squared plus 9. Feels like it might be able to factor. There's no greatest common factor, though. It's not a difference of perfect squares. It's not a sum of perfect cubes. So that actually cannot factor. So I'm just going to leave it as a binomial 2x squared plus 9. Okay, the bottom here can factor. All right, that factors using your Punnett square. That factors to be 2x and x, 3 and 3, minus here plus here. Okay, equals, neither of these can factor, so I'm just going to write it. All right, I want to pause, make sure everybody is kind of caught up. All that I've done in that red line is I did not change the problem. I just factored everything, and if it was a binomial, I wrote it in parentheses because we like how that looks better. Okay? All right, now, if you were half paying attention before, really focus right now. This is the major key. All right, I am attempting to do the blue step from over here on the right in this problem with all this algebra stuff in it. Okay, and it's very hard for me to describe exactly what I'm doing, but I'll do my best and ask questions if you have them. Okay, but essentially what I'm trying to do is I'm trying to figure out what can I multiply every numerator by to get all of my denominators to cancel out. All right, let me say it again. I need to figure out what I'm going to multiply each numerator by. There's 3 of them. Okay, and it's got to be the same to all 3. I've got to multiply the same thing times all 3. What could I multiply all 3 by so that all of my denominators cancel out with them? Okay, let's start with this first term. I've got an x minus 3 on the bottom. Obviously, what am I going to need up top to cancel that out? X minus 3. Okay, so up top, I'm going to multiply by x minus 3. All right, I'm not done, but I know that at least that denominator is going to cancel. Beautiful. Okay, let's look at the second one. And I got to multiply by the same thing in all of them. All right, so I know there's going to be an x minus 3 here, which is good, right? Because that x minus 3 is going to cancel with an x minus 3 in the denominator. But not everything's going to cancel out yet. What else do I need to cancel out in that middle one? The 2x plus 3. So I'm also going to multiply by 2x plus 3. So now my 2x plus 3 will cancel, my x minus 3 will cancel, so now all of those denominators are going to cancel. Hold up. Let me go back to the beginning. In the first one, I only multiplied by x minus 3, correct? Yeah. But I've got to multiply by the same thing every single time. So even though 2x plus 3 is not going to cancel with anything in this first term, I still have to multiply by that, because whatever I'm multiplying by, I've got to multiply by in all 3 terms. Same thing in all 3 terms. Okay? Which means, in this last term, I also have to multiply by 2x plus 3 and x minus 3. Well, heck yeah! 2x plus 3 is going to cancel that 2x plus 3, so that's a great thing. That denominator is going to cancel out also. Okay? Let's say, and there's not, but let's say there was an x minus 5 down here in the original problem. Everybody look up front, look at that in green. I just changed the problem, but let's just say that was there. It's not being canceled as of right now, correct? Yeah. So what would I have to do? Multiply all of the numerators also by an x minus 5. Even though that x minus 5 wouldn't cancel out in the other ones, since I have to multiply by the same thing, I would have to multiply all those numerators by x minus 5. Okay, but that's not there, so I'm going to get rid of it. All right, let's see what happens. Hopefully some beautiful stuff happens right now. First term, x minus 3 cancels with x minus 3, yes? Beautiful. I'm going to write what's left. I've got 2x plus 3 times x. That's got to be distributive property, though. X times both. Okay, so I'm left with 2x squared, and 3 times x is positive 3x. Better go with that? And no denominator. My denominator cancels out. Beautiful. All right, next one. 2x plus 3 cancels with 2x plus 3. X minus 3 cancels x minus 3. Boom. No more denominator. Great. Is there distributive property here? Not really, because there's not a number there, but it's a minus problem, right? So that's like there's a negative 1 in front, so I technically am going to have to distribute this negative 1 times both of those, because it's subtraction. So negative 1 times 2x squared is going to be minus 2x squared. Negative 1 times positive 9 is going to make negative 9. So far, so good? I got my equal sign in here. Alright, my 2x plus 3 cancel my 2x plus 3. 1 times x minus 3, distributive property, although 1 doesn't change anything, right? So here I just have x minus 3, nothing changed. And I have something beautiful in front of me right now. I've got an algebra 1-2 equation that just needs to be solved with no denominators. Okay, real quick. First thing I see up front, 2x squared. And there's no power bigger than an x squared, but we have an x squared there. What type of equation is this?
Subtract the minus from both sides, right?
You always do that, yes, but there's a name for this problem, so I'm testing your vocabulary. If we have an x squared in the problem and no power bigger than that, then this problem has a very specific name. Starts with a Q. It's a quadratic equation. You've got an x squared and no power bigger. It's a quadratic equation. All right, here's the next question. I'm curious to see if anyone can answer this. How do you solve quadratic equations? You can factor it and then set each factor equal to 0. Great job, Fernando. There's one other way you can solve quadratic equations. Quadratic formula. In either case, you need to be in standard form, so you move stuff around so that it's ax squared in front, bx in the middle, c in the back, and then equals 0. And once it's in that form, you can either factor it or do quadratic formula. All right, but this technically is not a quadratic. You see why? Because when I combine like terms, my 2x squared and my negative 2x squared cancel each other out, gone. Yay! Now we don't even have to mess with the quadratic stuff. But there is one question in your assignment, I believe it's number 5, where you end up having to solve a quadratic. So you're either using quadratic formula or factor. All right, so let's see what we got. I'm going to do a couple steps at once. Okay, I'm going to do minus x on this side, minus x on this side, so I can combine my variables together. And at the same time, I'm going to do plus 9 here and plus 9 here, so that I can combine my constants together on the other side. I don't normally recommend doing this many steps all at once, but this is an algebra 1-2 problem, and you guys are all the way in algebra 3-4, so you got this. All right, so let's see what's left. I've got 3x minus 1x, so here I have 2x. Negative 9 and positive 9 canceled. X minus x canceled. So I got equals. Negative 3 plus 9 is positive 6. Okay, divide both sides by 2. So I've got an answer of x equals 3. It's just amazing to me that if you took that 3 and plugged it into every x up in that problem, it would create a true statement. But that is how you solve rational equations. Okay, alright, that's it for this lesson. It's been real. There'll be another video coming in a day or two. Until then, deuces.